Good morning, good afternoon, everyone. Thank you for joining today to our webinar, Virtual Factory Building and Optimization. We will be waiting a little bit for everyone to join before starting. We will start in 1 minute. The replay and the presentation of this webinar will be available on our user communities. We will send you an email after the session when they are available. Today I am with Tuncer Dink and Aliasgar Anaswala, who are both industry process consultants. They will be your host today. And this afternoon, for the second session, you will have Tuni and Kumar Batalada, also industry process consultant. You have a Q&A tab where you can ask your questions. Our speakers will answer your questions after their presentation. I think we can start. Tuni, the floor is yours.
Thank you, Omar. Good morning, everybody. Thank you for the intro. So what we will talk about today is the virtual factory and optimization. So let's go to the next slide. We added some customer testimonies. We will not go through the videos because they're quite long, but we added the YouTube link and also the videos in the presentation. So you feel free then to look in the videos later on. We have a lot of material also in the presentation as videos, so feel free to look in it and ask your questions then in the Q&A section. Thank you. Okay, what are the today's challenges in a virtual factory? So, in a production. So we have challenges. Can we meet our production targets? So how is the inventory? What do I need as a stock in the warehouse? How can I optimize my production and the productivity in my production? How do I identify a bottleneck and how can I eliminate this bottleneck? How to optimize manufacturing process? All these questions are questions and challenges in today's production. Also, how many operators do I need? What in which and how many shifts do I need to fulfill my customer demand or my target? So here a short overview about our virtual factory solution in the 3D Experience platform. So we are covering with the layout building, with equipment simulation, factory flow simulation, all these topics which are necessary today for a virtual factory and for a factory analysis. On the left-hand side, when you see the layout building, we are supporting it with a 3D geometry, with library. We will talk later on it in a more detailed view. In equipment simulation, you are able to analyze your equipment, means with the mechanisms, with all the distances and clash detections. You're able then to analyze your toolings and equipment in a more detail and simulate them for sure. And in factory flow simulation, we are on a quite generic view on the factory and analyze bottlenecks, intralogistics, capacities, warehouses, and also the production areas. So these will be shown now in our webinar, and thank you for joining, by the way. And so let's go ahead and see what will be the next. So here you see different roles. We have a layout engineer, simulation engineer, industrial engineer, automation engineer. So how do they collaborate today? In the 3D Experience platform, we have a big value, which is the collaboration. So at that time where I start to do my plant layout design, and what is the key value of the plant layout is to use 2D information from as a DXF file, DVG file, means files from AutoCAD, MicroStation, Bentley, and other systems. I can draw and extend my footprints. I can position my resources. I can use point clouds and scans. And These all supported by catalogs and libraries to have where my content is inside, means buffers, storages, pillars, and so on, my infrastructure elements in short. So my simulation engineer can then use these equipments or can enrich his equipments with logics or intelligence, let's say. So we can do our tool design inside the 3D experience platform, forward inverse kinematics to use motion controllers and talk about or use our travel limits then to validate and analyze the movement or the behavior of the machine. Equipment validation, collision detection, cycle time is sure a part of that, and so we can push back this information also to the planning back again if necessary. At the same time, we use then the layout for factory flow simulation, for sure. Here you have a full discrete event simulation solution where we analyze our throughputs, bottlenecks, failure analyze scenario manager, means that we can do experiments and analyze also then our resource pools. Resource pools can be AGV, can be operators, so how many resources, how many carriers, how many AGVs do I need during the production. In virtual commissioning, we are talking about integration of our PLC. So with the shared memory, we can connect to software in the loop, hardware in the loop. And so we can validate in virtual commissioning then the PLC with the virtual environment. And so we are sure that our PLC is correct or we need to change something. This video shows you plant layout design. So we start then, as you saw previously in the roads, from plant layouting. You see on the right-hand side, the library manager with classified resources. I'm able then to place my resources inside the building. So it can be a BIM building, IFC format, or you have a connector to Revit. And so we are able to use the real a building to instantiate our resource from a library. And you see here how easy we can align and distribute our resources in the production. Also with advanced tools like Snap, Cumulative Snap, we are able to position the resource on the correct location. You see here on the table, or change also the references of the objects easily to place them correctly in the rack. Here we see a small deep dive. So it is a very detailed information then by the end. You see here also the robots which can be programmed then in equipment simulation and virtual commissioning. So that means we have a huge robot library which has a lot of different robot vendors to be used. Here you see the point cloud section, very powerful. So point cloud, E57, XYZ, ASCII, and so on. We are able to import these point clouds directly into the 3D experience platform, and we can recognize here different objects. You see here the robot can be recognized, replaced, and later on you can do your offline programming directly using a point cloud, because we don't have always factory design, or the buildings are quite old, and so we need sometimes scans to bring it into the 3D experience platform. You see here also some news in plant layout, which is also quite powerful. So to change the visualization of the point cloud, sometimes it's difficult to understand dependent on the points, how many points are in the scan, what is the geometry, which geometry do we have. This is a quite new functionality to change the visualization of the point cloud. Here again, you see a huge factory, so and easy methodologies. The difference here is it's not in the 3D experience platform directly, it's in the web browser. So FLR is a new functionality, a new role where we can do your layouting in the web browser in a widget. And so you're able also to do your layouting directly from the web browser. Same here is still factory compose, means as a role FLR. And so you are able to do your layouting everywhere with the web browser connected to the 3D Experience platform, and easily you can instantiate your objects from a library directly from the platform to your layout, and so immediately you can then prepare the session for anybody else who needs to do a factory flow simulation or any other thing. So we see here how to place the machines, how to position the machines, how to generate the resource structure, to rename the objects, and to position them correctly in the layout. Very easy, fully supported through the web browser, and the role, as I said, is Factory Compose, FLR, and fully web-based. So here we see a quite important topic, not to say that the others are not important, but this is a PPR context, means product, process, and resource. Quite simple scenario, but very powerful because it's a configured product structure, a configured emblem, and also a configured process. Means we use here different product variants. They are planned in a 150 EBOM, 150 MBOM, and 150 process. You see here how we do the in-session filtering, and dependent on the variant, we see only the processes which are necessary. And this is fully integrated into factory flow simulation. You see by drag and drop, we assign the manufacturing BOM into the in zones, and the same we do then with the processes. That means we consume the entire planning information into the factory by drag and drop. So here you see the process structure, means station information, processes, process sequences, process times are used by drag and drop into factory flow simulation. And then the driver is not anymore this guy who is doing the simulation, factory flow simulation engineer. The driver is here the process planner who plans the process, who decides in which station, which processes needs to be executed, with the time, estimated time, analyzed time, enriched by time analysis. And so the driver is always a process engineer. And at that time where we get a new revision of the process of the MBOM, of the EBOM, it will reflect then automatically the simulation. And so you have an easy integration from a PPR planning structure to factory structure, which will simulate then the process information easily. Here you see how to access the configuration. So here we generate the configuration sets, means everything which was done in the process is used in the simulation. And so we define which variance needs to be reflected in the simulation. It's kind of filtering. So, and when the configuration sets are done, we can decide, okay, what is the customer demand, means the production schedule, then to produce these different variants in the in this line. Great. So, and here we see then on the machines the different schedules. So here we say, okay, in which sequence we want to produce this information. So all these variants needs to be produced. And then we define on a simple Excel file the production schedule, in which sequence we need to do the production. So simply defining the sequence, and that's it. Sure, for any other machine we need the same. Depends on push and pull. My friend Ali will later on explain you also the Kanban. Kanban is also main functionality in factory flow simulation, which acts then in a pull mode and will then do it by Kanban cards, but this is something what Ali will describe later on. So, and then we have the last machine. So, and you see everything is in the is out of the box in the user interface. So you don't need to code anything. There is a a logics information which can be coded, but this is only if you need some specific behaviors on specific machine and resources. Most of the functionalities are out of the box and in the user interface. This makes it very simple also for a layouter to do a simple simulation without to have any knowledge in programming. So, and you see now easily these variants are produced dependent on my production schedule. And so you see the machines running, the conveyors running, because all our resources have already the intelligence to be simulated. So, and if you have any other geometry which is imported, you can easily do it in equipment design or equipment simulation, as Ali will show later on, to be able to use it in the simulation in the factory.
Thanks, Tony. Thank you for the information and insights. Everyone, thank you for joining the webinar. I'll take it forward with the equipment simulation and some good functionalities on factory floor simulation. Let's start with resource-centric simulation. In a way, what we do when we have to simulate something as a resource level. Here we have a 5-axis industrial machines and some engineering connections are defined onto it, develop some kinematics. These are between the specific elements of the machines. Related to this engineering connections, these joints and commands are created. Now, inside equipment design, we can check which mechanisms are there, and as a mechanism manager, what is the degree of freedom status, allowing to jog them with respect to individual axis and creating a kinematics as well. So this inverse kinematics can be done with the robot, can be taken forward. Next is to define some home positions within this so that they can be directly used when we are teaching this machine for some programming, NC program, or even to use it directly in factory floor simulation. Travel limits can be defined onto it, providing soft limits as well. The color coded will be there for soft limits, defining that it cannot go beyond this point. So while simulation, it will give some warnings and signs. Next is to simulate the equipments inside equipment simulation. Here, if you see, this is a master task where the sub-services or the sub-tasks from individual robot cells are called upon, and they will run parallel because the functionality is provided in a such a way. There are other conditions that can be applied as a weight falls and other things. More to these things is if you go to the individual robot cells, then the control equipment is defined for this particular robot equipment that will allow us to use it for different functions as well, for different cells as well. In the setup, we can teach the program for this control equipment for this particular robot and see the individual conditions can be applied to this individual robot, and it cannot be like just to the main task. Here we have defined some grab activities, some false conditions, and the release activities to have a realistic scenario of how it will perform in the actual environment. Now, these signals can be linked with the robot input and output signal as well. Once we come out of this teach pendant and click on the control equipment, it will show us the signals that has been generated at the resource level. This can be propagated to the master level. This is for robot cell B. As an input output, signals are provided. The same can be seen in the IO mapping editor for this robot or for this control equipment as well, where we have linked this with the higher level to have a multi-robot simulation like this way. This is for robot B cell. The same is applied to robot A cell, and then it is propagated to the master cell. Inside IO mapping editor, we can have these definitions. So both the robots are interconnected with each other. So to avoid the interference and interlock with each other. Now, when we simulate this as a master task, we can check the live signals when the simulation is running, which task is running, and even we can play and pause those tasks. So this really helps if we want to do a equipment simulation at a resource level and understanding what are the collision impact, what are the cycle time of this robot, and then later on take this when we are doing factory floor simulation. If we want to stop one of the robot and see how the other robot is performing, we can play and pause those tasks and have an overall idea. This was all about the resource-centric simulation. we now go forward to factory floor simulation. In factory floor simulation, we'll first take the Kanban management. When we say Kanban management and when we say that we want to run the production system on this aspect, it is in a way to run it in a pull mode. Now there are basically two modes, push mode and pull mode. Push mode is about building things built to stock, like we have in a T&M industry or automotive industry, where we build items, stock them in the inventory, and later on push it into the market. Against that, there is a pull mode of working, which is a kind of a build to order, like in a high-tech industry or in the aerospace and defense industry, where we produce as per the customer demand or we produce as per the order that has been received by the company. Here, based on the order specific to that order, we pull the parts into the production from the supplier side as per the demand in one way to also implement the just-in-time manufacturing scenario. We'll have an understanding of how a typical Kanban production loop will work. So based on the customer demand for week wise or a month wise, we prepare a production demand planning for that particular week. Based on this production demand planning for different assembly lines, we build a dispatch order or a labeling board, which allows us to define which product we need to dispatch as which point of time from the resources or the dispatch area. With the help of this labeling board, the production cards and the withdrawal cards are triggered. Based on this dispatch order, one withdrawal card will get triggered at a particular time, meaning one part will be dispatched from the company to the supermarket or to the customer area. This triggering of withdrawal card will pull one item from the safety stock, and this will pull ultimately a production card, triggering the production line to build one more item on this, generating a request. Basically, triggering of the production card will pull an item from the pool stock or from the supplier side. So the supplier will get an intimation to produce one more part. Following this way of production allows us to maintain majorly the inventory level, stop the overproduction, and meet the customer demand in a way to have a just-in-time manufacturing scenario. We have created a short scenario or demonstration of both a push mode and a pull mode. So in this video, we'll talk about when we run from a push way of working where we have excess supply and how we can avoid this kind of challenges when we run in a pull way of working. So this is a small setup where there is 3 assembly lines, a dispatch area, and a supplier side. Here, there are 5 different products that are manufactured, and for these 5 different products, these are the groups based on the customer demand. This schedule has been provided over here on the supplier side. So it will, in a push way, continuously push the parts to the assembly lines. So when we start the simulation based on the distance, it will produce items on the supplier side and continuously push on the assembly lines. So this is the feeder area for the production lines. From here, the parts will be individually sent to the individual assembly lines as per their definition. After a certain time, this will be overcrowded because there is a limited inventory over here on the feeder side. And with the excess supply, the line will be keep continuously pushing on to produce more number of parts. So what we see over here is the number of buffer or inventory at the start of the line, overcrowding or hitting the upper level of the inventory. Let's say by 1 hour we produce this much of stock or one lot, but we have most excess of supply over here. So this is overcrowding in one way. That is one of the challenge. If we check the queue length for the buffers, it's always high because of the excess supply from the supplier side to these production lines. Going a little fast, and after 1 day of simulation, we have these records, while at the end of the supply, we will able to produce 225 parts. Now, against this push mode, if we run the pull mode, here, first of all, we will define some production card and withdrawal card for the products that we have to produce. We will apply on the dispatch side from and to resource from where this card will get triggered. And the production cards will be applied to the machines on the supplier side, which will push the supplier to provide the parts when they are required and not before that. The dispatch logic triggers where this withdrawal cards needs to be applied on the machine. different dispatch logics are set as per the lines, because these lines produce 5 products. So in a way, multiple products are produced as per the customer demand. In labeling board, as per the timestamp, we define the card. Now, when we run this, we start at a 1 minute for the withdrawal of one lot of items. To pull the simulation, we can see in the board and the global panel what are the active production cards, or which are the ones in transit that they will be triggered next for producing from the supplier side. Now, this is all with respect to what is required on the line side, not in excess way. If you see these things, this is the inventory level 00. Nothing is so far available. Whatever is available, that has been sent to the production to produce as per the customer demand. This will be filled up when there is a need or when the card is getting triggered over here. So based on the withdrawal card, a card gets triggered on the production side, and this trigger allows the supplier to produce one more part and send over here. So everything works in sync. We manage the inventory level, we manage the overcrowding over here, we manage the excess production in the line, and have a smooth supply to the demand ratio. So by the end of the time, we produce the same amount of parts as a lot, but we remove the challenges. So this is how we work with a pull way of working, mostly for the intralogistics, for the inventory management, and for implementing a just-in-time manufacturing scenario. This supports well in EFS. Next to this is to talk on how we can implement shifts and the other things, the calendar time into the simulation. If we have a simulation model that we would like to run it for some months and years, and we would like to apply the shifts into it, then with EFS, this is possible. The major functionalities of calendar and shift is to create different shift types, marks as dates and as a holidays. Allows the one of the important parameter is to uh, put some resources in one of the shift, and if some resources are not available for the other shift, we can omit them and then see the simulation how it is working. So as per the production systems, the staffing strategies vary in the morning shift, in the evening shift, and by running them and understanding what will be the output of this, when we run it with different resources available, we can manage these staffing strategies as well. And we can understand that based on the number of employees available to run the simulation or the production system, what kind of impact we are getting on the throughput side. Going a little technical, in this video, I've showcased how we can define a shift schedule. So these are morning and evening shift, and particular breaks are created. We can assign them into the shifts. So in the morning shift, I have assigned coffee break and lunch break, and in the evening, dinner break and coffee break again. Now this shift, I will apply to the calendar for a month. This is one of the shift model. I can mark the weekends as holidays for the entire month. Now, the same shift I can take from the table and apply for one day. Then I can repeat the day shift to the entire month, selecting the right start date and end date. Even this can be like pull up for some days as well. Like once based upon the selection, it will apply to the particular days. So the morning and evening shift has been applied to all the days of this month. You can create multiple shift model as well. Like this is the first shift model. If you would like to add another, we can add. Now here, even though I have added for 1 month, but I would just like to run it for one day. So you can set the simulation start date and end date accordingly. I would like to run this for one day, 25th of September. Here we can activate based on multiple selections, and then we run. So now when we run this, first we see that at 00 hours, they are off shift. It will start by 8 o'clock, 6 o'clock in the morning, as the shift morning time of the shift starts at 6 o'clock and it will last till 830 hours, 830 hours. In order to run it quickly, I am just manipulating with some preferences. So I'm increasing the step size and I try to see. So at 6 hours, the system is started. Machines are now running. The resources are working. This charts gives us an indication that how much part are currently produced, what is transferred, and what is the current utilization of these machines. I'm sorry, I'm going a little fast since I have to cover many things. So with this simulation, by running after 1 hour, we'll have two different scenarios. So going to system performance monitor, we can take out the results in HTML format for shift wise. So from that selection, we can see the morning shift. Here we can understand what is the utilization in the morning, what was the worker utilization, how much products he has transferred during the morning shift, and relative to that we can see in the evening shift where we have the less number of workers. So I have only assigned 4 workers in the evening shift, and in the morning it was 6 workers, 6 to 7 workers. So we can see the drop in the utilization, drop in the overall throughput because of less number of workers, because of unavailability of the resources. This is the comparison between the utilization and the products transferred between two different shift models. So this was all about how we can implement a simulation based on the calendar time, and how we can run a Kanban system. Next is about a scenario manager. So I'll ask Tuni to take this forward on the scenario manager.
Thank you, Ali.
Tuni?
Oh,
Sorry, I would like to just
no
make it.
problem. So in the scenario manager, quite important. So what can we do? So you can run a batch mode, clear to have a report as Ali showed before. But here we want to compare different scenarios to each other. So we are selecting first resources which should be tracked. And here in the activity selection mode, you can define from activity, machine, AGV, any resources, resource pools, operators, which should be a part of the experiment. So, and here we define different scenarios. So you see here the machines are activated, deactivated. It's a parallel line. And so we play around with the parameters from a user interface, which is very simple because you see here the different scenarios compared to each other. And you can directly change the parameters in this user interface. And so by the end, we can add as much as scenarios as we want, and increase, decrease the values, change the times, activate the resources, define how many operators we want to have in each scenario. And so you play around with the different values inside this user interface. We define what should be the scenario output. So we need to select then the resources for the outputs. Could be that you play with the machines and the times, right? But the output is then only the AGV or only your out zone. So we define then according to our request or according to our validation, what should be the output by the end. We define the simulation time. You see here we have a warm-up time, simulation time, and how many random seeds you want to have, so how many runs. Or you do also a warm-up time estimation before, it depends, could also be done in the batch. And you select then how many, which of these scenarios should be simulated. And so you see then as a result in the web browser, in the panel, then the HTML file or the XML file if you want to use these results in other tools to do the visualization. At the same time, you can export this information as HTML file or both. You see here XML, HTML or both. And so you can open it directly or attach it directly to your line, or you have it on your hard disk and you can open it on the web browser. And this enables you to simulate fastly different experiments. And so you are very fast to compare your scenarios, to validate your production, and to do the best optimization which is necessary. So what is the key differentiator of the 3D Experience platform? So we see how we connected all these dots together. So coming from a product, you saw the PPR context means we had manufacturing structure and a process structure inside. On the resource structure, either you do a direct simulation, means resource-centric simulation, or a process-integrated simulation by assigning the processes into the resources. In total, we talk here from the PPR context. So with the factory scan, with your plant layout, with your process information and the resources which you added, you can do then your factory flow simulation to do your validation, and then a step forward to do your virtual commissioning by connecting your PLCs to do a software in the loop or hardware in the loop. So what are the key values? So first, we reduce time to market. We validate our production system by building first time right. We can simulate what-if scenarios and eliminate any production challenges. We improve our equipment design. You saw Ali did the kinematics, changed the distances, did the validation, did the collision check. So we validate this tooling, we interact with equipment, we make the design collision free. We do a better floor space utilization. So we have 2D information from other systems, as I said, AutoCAD, MicroStation Bentley, and so on. So the XF TVG format, so we can effectively manage the space in placing our 3D objects on it. We do the simulation then, and so we can optimize also the positions and the distances between our resources to eliminate unnecessary walkways. And we can reserve space for future expansion. Means in a brownfield scenario, you have then also the ability to say, okay, what happens when I need to build another line, an additional line, a parallel line? So where should it be? How is it then the intralogistic between these two lines? And so we can already think about in the future and say, okay, where should this space be allocated? We optimize our system throughput, so we understand where is my bottleneck, what happens when my system breaks down, which repair and maintenance activities do I have, how many operators do I need for this, who is the operator who will do the maintenance. And so we see the resource utilization, and we can think about the utilization and eliminate high utilized resources, not only operators, also AGVs, workers, and not only AGVs, also operators and machines. So thank you very much for listening to our webinar. Hopefully you enjoyed.
Thank you. Thank you, everyone.
Okay. Any questions from the audience? Feel free to ask them in the Q&A tab. Otherwise, the replay of this session will be available on our virtual factory and robotics community. I will share the link in the chat, and we will send you an email once it's available with the presentation. Tuni, Ali, thank you for this great presentation. I think if there's no questions, we can close the session.
There are some.
Okay. Yes. I let you guys respond.
So there are a few questions. Tuni? Okay, I'll go through one of them.
Okay.
So the first one is about how many number of test runs can you perform with one simulation run in Scenario Manager? You can try with multiples, as Tuni has shared. He has created 5 different scenarios and did simulation run for that. You can validate so for that, and it's not limited to 5. You can increase it, but it really depends on how long you want to run, what kind of scenarios you have in one shot. So you can try it out
no
for multiple
limitation.
runs.
So also with the random seed, so you can define the scenario, how many scenarios you want to have, and how many runs you want to have in this scenario. So there is no limitation known, so it's open.
Yep. Thanks, Tuni. So the next question is from Henry about the pure web solution. Now, the pure web solution is about building a plant layout at a concept level using the web app, where you don't have to open the native application and you don't want to go in detail. With the available resources on the platform in the collaborative space, if you have to quickly build a layout for a concept purpose to showcase to the hire manager or to a potential client, or even to the shop floor people, you can directly create a short concept based on the discussion being in the meeting and then have an understanding or evaluation out of it. So for that purpose, the pure web solution is offered.
Also, we have to say that most of our applications are also available in the web, also because we offer the cloud, right? And so you have also the process emblem definition already as a web-based solution, so MFN, MGA, and so on, PMR, to visualize not only the process, also to validate the process for with the product build-up. And so the next step is also to bring then other roles into the web to simplify then the usage and to open it for more attendees or for more users on the 3D Experience platform.
Thank you, Tony.
Thank
So
you.
there's a question on equipment kinematics.
Mm-hmm.
So the difference between forward and inverse kinematics, actually, it's so the forward kinematics allows us to move the particular joint where the kinematics has been defined. With inverse kinematics, it's calculating the joint of all the other commands that you have defined, commands, non-commands both, and allow you to run with respect to one TCP that has been applied on one of the joints. So seeing a robot moving, it is purely because of the inverse kinematics defined on the robot. For the machines, basically you have forward kinematics defined where the individual joints will move and the other joints will not have any impact on it. In order to have a synchronized impact on all the joints moving with respect to one another, you would like to define an inverse kinematics on top of it.
Mm-hmm. So can you explain briefly why should someone move from DELMIA v5 to DELMIA v6? This is very simple, because DELMIA v5 you has a flat or a file-based system. You connect it to a PDM or PLM system. Since the 3D Experience platform has everything connected, that means you have a vertical platform, which a horizontal platform, which is the 3D Experience platform, and all the roles, all the brands, Eneovia, DELMIA, and so on, are vertically connected to the 3D Experience platform. So everything is integrated. The collaboration is much easier. And you are much faster then to do your design and validation, because through this connection and collaboration with everybody, you are much faster than in your daily tasks. This is quite simple then why we should move from DELMIA v5 to DELMIA v6. Okay, I need a detailed video on how to use environment. Okay.
Yeah, I've answered to him.
Great.
So the presentation will be shared later with the webinar organizer, and you can have the videos from there. If in a case you would like to discuss your industry scenario, so you can connect with us and we'll move forward with that. How flexible is DELMIA in connecting to other simulation platforms?
This is dependent what we want to exchange. So the 3D Experience platform offers a lot of interfaces or a lot of exchange to other systems. Depends what you mean as a simulation. So connect to us, and then we can discuss what you want to exchange and which of these simulation tools you mentioned. And so.
Yeah, thank you, Tony. So this one is from Nitin. Okay, this is more on the EGV trains inside factory floor simulation. Can EGV trains work according to a request generated? It is observed that EGV trains are moving on a defined route. Yeah, we can simulate the EGV train in factory floor simulation. With the enhanced capability, you can pick parts from multiple locations. You can have a pack done on the simulation as well. And if you would like to park them, then here going into detail, it is more about how you define them. So the train runs on a defined schedule. It will go to a parking zone if it has completed one loop of time based on the activities defined. Once the loop is completed and for the next loop there is some available time, it will go to the parking zone. Just in case you are running the train simulation where the time required to complete one loop is more than the frequency, then it will not go to a parking zone and it will try to address the other loop. So based on that definition, it works. We have to check what is the loop duration, and according to that, we have to define a parking.
I take the question from Hemant. So yes, you can import, but it's not a must. You can also design inside the 3D Experience platform, because CATIA is a brand of the 3D Experience platform, and so you have the full designing environment for your 3D parts or assemblies or surfaces. So you inside the 3D Experience platform, you have the fully capability to design to do the designing. So no need to import files. You can design it directly. And this is not DELMIA. This is then, as I said, the brand DELMIA, CATIA, sorry. And so inside CATIA, you can do everything what you want. And since we are connected all to the same platform, we can use it directly for our production planning. Exported, you can also export it, but when we talk about the presentable format, if you want to present something, there is no export needed, because also the web browser capabilities are here with 3D Play and other widgets, where you can connect with the web browser directly to the platform and visualize everything what you want. So your 3D data, your embalm, your processes, your factory, even the animations of your simulation. So you have a lot of capabilities using only the web browser and connecting with your credentials to the 3D Experience platform. And so normally there is no export necessary.
Thank you, Tony. The next question is on the FLR role, where the attendee would like to understand if we can open a plant layout prepared in the native app on the dashboard using FLR role. So yes, basically the FLR role is to quickly create a layout. If in a case you already have a layout prepared using native apps inside plant layout design application, you can certainly open in FLR and showcase. But the main idea to have a FLR role is to quickly create a layout and not for viewing purpose, while it is still perfectly fine to view it if a layout is already prepared.
Mm-hmm. I go to, thank you, Ali, to AnyLogic, for example. You mean simulation tool as AnyLogic? Question is why to connect to AnyLogic? Because you saw Factory Flow Simulation is a full discrete event simulation tool. So you can do your simulations there. But let's say you have in AnyLogic a simulation and you say, okay, I need to jump from AnyLogic to Factory Flow Simulation, which would be cool, right? So you can then we can then think about, okay, which kind of format support AnyLogic to do the export, and then we can import it into the 3D Experience platform. And when AnyLogic can export any XML format and so on, most probably we can overtake this information then also into the 3D Experience platform, but we have to see which kind of support AnyLogic offers here.
Thanks, Tuning. I think the last one is on, as a comment, it is coming from the attendee. All the files are saved in cloud. Yeah, so the 3D Experience platform is based on cloud. Now the cloud is of course safe. You can store the file in the cloud on the platform in the collaborative space. If you want to store locally, then you can export and store, but that will unnecessarily occupy your local system space. And in a way, saving it on the cloud will allow you to open it quickly next time on the platform from any place. So you're not dependent on the independent machine that you're working using the cloud solution. You can access it from any kind of system, from any place, and then have the access to the right files or the latest files. So that's the advantage of using a cloud solution on the platform. Thank you for attending. Thank you.
Thank you very much.
Yeah, I think we are at the end of the questions.
Okay. Thank you, everyone. Again, the replay will be available on the Virtual Factory and Robotics community. I've shared the emails of Ali and Tuni. If you want further information, don't hesitate to contact them. I thank you very much for joining us today and wish you a nice day. Thank you all. Bye-bye.
Thank you,
Thank you,
Roma.
everyone.
Bye-bye.
Wish you a
Thank you, everyone.
fantastic day. Bye.